Hi there, thanks for watching. So what we're going to do in this video is we're going to run through the examples that we did in class. Okay, so first thing you're looking at is a page of guided notes that I handed out. So if you do not have this, you need to go back to the outline, and I linked a PDF of these examples. So you've got two choices. One, you could print it off, which would be the easiest choice, or two, if it's not possible for you to print, then you're probably going to need to pause this video and go back to the PDF and take, 5-10 minutes to copy these examples into your notebook and leave some space in between for us to work through. All right? So when you're ready, what we're going to do is we're going to run through each example. You're going to try it on your own first, then you're going to hit the play key, and we'll talk about the answers and maybe help you with anything you're misunderstanding. So for example one, we're going to bring back some vocabulary. I would suggest right now that you go get the vocabulary and study guide that we did last class, right, where we talked about all those words like trinomial, quadratic, all those new like polynomial vocabulary words. So for example one, you're going to name each polynomial by the degree and by the number of terms. This table, what you're looking for, is on the back side of your notes. There's two tables about classifying polynomials. So when you're ready, you're going to try them on your own, use the table to help you out, and hit the pause key. And then when you're ready to go over your answers, then you're going to hit play, and we can talk about what things you did right and what things we need to correct. Okay? So ready, set, try it on your own, go. Okay, so let's go ahead. Let's talk about your answers and how we name these. So first thing, when I look at part A, I see that the highest exponent, that means it's the degree, is 30. And what we call a third degree is we call it a cubic. Now, this polynomial has 4 terms. So if you have 4 or more terms, we just kind of call it this blanket polynomial, right? We don't have a special name for 4 terms, 5 terms, or 6 terms. It just becomes a polynomial. All right, for part B, the degree, the highest exponent there is 4, and so that is called a quartic, and the fact that it has 3 terms makes it a trinomial. So when you put it all together, we call this a quartic trinomial. For part C, a little tricky, you don't see the exponent, so we talked about how if you don't see the exponent, you assume that it is a 1, okay? And so this has a degree of 1, which makes this a linear, and it has 2 terms, so it's going to be a linear binomial. All right? For part D, the degree is 2, which is called a quadratic, and it only has 1 term, so this is a quadratic monomial. All right, part D is a little bit tricky because we don't see the exponent, and the reason you don't see a variable or an exponent is because this is like having a 5 and then having an x to a 0 power. Well, if you have x to the 0 power, that means basically you don't have an x. And so what we call something that's to the 0 power, or what we call just a number without a variable, is we call it a constant. Okay? And it's a constant, since it's only 1 term, we call it a constant monomial. So a constant term will always be just a monomial right there. So the last one is we've got a degree of 6, which doesn't get a special name. Okay, so we would just call this a 6th degree. And again, how many terms do we have? 1, 2, 3, 4, 5. And so we would just classify this as being a 6th degree polynomial. Okay, so hopefully that helps a little bit with some of the vocab. Let's keep going. So now what we're going to do for example 2 is we're going to use the vocabulary to now write our own little expression. So we're going to write a cubic trinomial with a leading coefficient of 5 and a constant term of 12. Sometimes I need to read these a couple times just to make sure that I get the information. So when I hear cubic, cubic is going to refer to the degree, and so that I know that I'm looking at having an x or a y or whatever variable you want to the 3rd power. Trinomial means it's going to have 3 terms. So now let's start putting this together and see if we can't make some sense out of this. So the leading coefficient is going to need to be 5. So we're going to need to write something like 5x cubed, and then I'm going to have a constant term of 12. But I needed to have 3 terms, so I've got some kind of middle term right here, and then I know that the constant is going to need to be 12. So this right here is the constant, and I know right here that I have the degree right there is going to be 3, which is cubic. So probably what this means is I can kind of make up anything, honestly. Anything on that blank is as long as it's, you know, it doesn't have a degree bigger than 3, but you kind of have some flexibility with what you want to put in that blank right there. So then I just kind of give it a final read, and I look at it and I kind of say, all right, it's cubic, check. There's 3 terms, check. Leading coefficient is 5, constant term is 12, and I give it a reread, and I know that I've got everything. All right, so then what we get into for examples 3 and 4 is you're going to practice combining like terms with addition and subtraction. So again, what I'm going to recommend for these 2 examples is I want you to hit pause, and I want you to try them on your own first, okay? And then we'll go over the answers, and you can just kind of like check your work along with me. So ready? Try it on your own, go. All right, if you're ready, we're going to check our work. So the first thing that I'm going to do when I work through these is I'm going to rewrite the expressions without the parentheses. Okay. So I'm trying to get this to not move. All right, so this is basically like having a 1 in front, and by putting a 1 in front basically means that nothing in this first parenthesis is going to change. So I'm just going to rewrite this as 14 minus 4 plus 3a squared. Again, this is like having a 1. And so when I distribute this, it's going to be minus 3a squared, and nothing really changes right there. So I just like to go through and I rewrite it without the parentheses. Okay, and then I'm going to go and I'm going to start combining like terms in order of degree because we want our answer written in standard form. So the highest exponent, the biggest degree I see here is negative 4a to the 4th. And there's nothing to combine it with. And so I'm going to leave it as negative 4a to the 4th. So I kind of like to cross stuff off as I go. The next thing that I'm going to notice is that I have, my next degree is going to be a squared. Well, I have 3 squared, a negative 3a squared, and a negative 14a squared. So the 3a squared and the negative 3a squared are going to essentially cancel out, right? And so I'm going to be left with minus 14a squared left over. So now we got all of our squared terms. Finally, we come to the constant terms, and it's a positive 14 and we have a negative 8. So positive 14 take away 8 is going to be a plus 6 at the end. So not only have I combined like terms by adding and subtracting, but the second thing I've done is I've written the polynomial in standard form. Okay? Not sure why it's not boxing in. Okay. All right, let's take a look at the next one. Now, this is a little bit different because this one's going to be subtraction. So what I'm going to start by doing is I'm going to rewrite the first parenthesis. Since there's no number in front, we are essentially distributing a positive 1. But here it's important because this now becomes a minus negative 7x squared, which becomes plus 7x squared. And then this becomes a minus negative 5x, which becomes a plus 5x. And then I need to make sure that all the way here at the 8 that we minus the 8. So it's really important with the subtraction that we distribute the minus sign so that we minus every single term. So we're going to do the same thing. We're going to combine like terms in the order. And so the biggest exponent that I'm seeing, so let's catch up a minute. All right, so the biggest, what's going on with this? Okay, there we go. All right, so the biggest exponent that I'm seeing is going to be a cubed. And so I don't see any other cubes here. So in fact, I'm going to bring down 4x cubed in red. The next one that I see is the squared. So I'm combining a negative 11x squared and a positive 7x squared. And that's going to be negative 4x squared. Okay? The next thing I'm seeing is this linear term right here with 4x and positive 5x, which is going to combine to make a positive 9x. And I like to cross these out as I go. And then finally, the constant term's negative 8, and there's nothing to combine it with, so I'm going to bring down the negative 8. Okay, so again, we've successfully combined like terms by subtracting, and we've written our polynomial in standard form. All right, so last problem is we're going to see a lot of perimeter problems because perimeter is just the sum of all the sides. So it's a way to apply what we're learning about adding polynomials in just kind of a different setting. But this is going to be a little bit different, okay? So basically, I'm giving you that the perimeter is going to be x squared plus 4x plus 6. So what we're going to do is we're going to take all three sides. So if I take 3x minus 1 and I add that to the side that's given x squared plus 2, and then I add that to this question mark, which is that side I don't know, I know that all three sides will add up to the given perimeter x squared plus 4x plus 6. Okay? Well, what we can do then is we can combine the terms, and I can combine these two sides to be x squared, and then I don't see another, so I've got plus 3x, and then what I see is the negative 1 and the 2 can combine to make plus 1. And so that's what I get when I add the two given sides, and it's going to equal this perimeter, x squared plus 4x plus 6. So now really all I need to do is I just need to subtract. And I'm going to set up right here a little subtraction problem. So really what we're doing is I take the given perimeter, x squared plus 4x plus 6. It's right here in words. This is the given perimeter. That's the sum of the whole three sides. And I subtract that from x squared plus 3x plus 1, which is, let me kind of make some room right here. I'm not sure why this is not working very well. Okay, and I subtract that from the given sides, and what we can do is we're going to equal the missing side. So let's practice the subtraction. It's x squared plus 4x plus 6, and now we're going to minus all of the terms. So it's minus x squared, and then we minus the 3x, and we minus the 1. And that's going to equal, again, that missing side. So let's combine our terms. Well, what I notice is the x squared and the x squared cancel. I see right here that we have a 4x, take away a 3x, which is going to leave 1x. And then right here we have a 6, take away a 1, and that's going to leave me with x plus 5. And that is what the missing side equals. So what I'm going to do for you before we end these is I don't want you to walk away with these problems being more confusing than they need to be. Basically, what you're going to do is you're going to take the given perimeter. Okay, let's make ourselves like a little formula for this as we see these later. We're going to take the given perimeter and we're going to subtract that from the given sides. And what that's going to equal is it's going to equal the unknown side. So it's really just a quick little easy subtraction problem. Okay? So hopefully this video helps. You can then go back to the outline and check out and see what your homework was. And hopefully you understand the concept. Bye.